Yeah, Jonas and I will give you an introduction on the Source project, and I will give an overview because that project is a EU-funded project with 9 partners, and it's maybe a little bit, I wouldn't say difficult, but that there is a story about the partners and the different areas, and I have to say that up front, even though there's been a lot of work been done already in light field exploration with light field rigs and how can we use that data creatively, Source is not just about light field technology, but we'll get into that in a moment. So Source is an abbreviation for Smart Asset Reuse in Creative Environments, and it's a project under the Horizon 2020 call of the European Union. It started officially in January 2018 and is scheduled for 3 years. So we're about at half time of the project. And even though I will explain all the areas of research and innovation, it's not uncommon that these projects have a rather slow start. The partners have to find each other. There's a lot of things to look into and to research before you actually start implementing and doing things. So keep that in mind. Yeah, the idea is to bring together technology, science, and the creative industries, and to create an increase of value from digital assets by making them smarter. What does that mean? We want to be able to discover and reuse existing assets and generate smart assets by new technologies like light fields, for instance, and also create content based on these smart assets. I will introduce say a few things about the consortium, starting with the industry part, which is, even though here at the very end, DNEG is the big industry partner, one of the big effects houses in the UK. Foundry as a provider for professional and commercial software solutions for film and creative industries. And iKinema, they're creating animation middleware, mostly procedural animation tools for real-time applications, games, but also for things that go way beyond games and support motion capture data. Disney Research is somewhere in between the industry and the academic partners. The lead of the project from the academic side is UPF in Barcelona, and the other industry partners are Saarland University, Brunel University of Technology, and Trinity College Dublin, and of course Filmakademie BW. So the core research and innovation areas of Source are, first of all, to automate the automated classification of 2D and 3D assets through machine learning. So imagine a big company like Double Negative has a lot of assets, also a lot of assets that they can actually reuse if they'd be able to find them. It starts from a backplate, but it continues to assets like an effects animation, a scanned mesh, and it turned out to be a very big challenge to really get an overview of all these assets and to have them. Once you have found an asset, then you could use a software framework for the automated conversion and management of that media. So the idea is you have maybe created a scan of an environment, and all of a sudden you realize, well, I want to reuse that, but I need a much lower resolution because we're going to build a VR experience and everything has to be real time. So by providing descriptors and a framework that first of all can find you that asset and then transform it, you will be able to reuse it in a different way. And you can apply that idea to all sorts of assets, even a character that's been rigged super sophisticated for a visual effects show, but then you might want to reuse it for a game, and then you send it through a conversion process that is mostly automated. The fourth field is research into light field technology, and there is actually a big body that Jonas will present in a moment of work that's been done there. And intelligent character animation for real-time usage also on set, and we'll get an introduction of that as well. With that I hand over to Jonas, who's going more into detail of the individual topics.
Yeah, so I will actually start with the search and transformation framework that we are working on. So multiple partners of SOURCE are working on that topic. And I can present you here now a first prototype of a search framework that we are looking into. It's developed by Heiko Riemenschneider. And so what it actually does is, first of all, of course, importing the data that needs to be searched in the database. There are multiple formats supported, standard formats like images, videos, also materials, so normal maps and so on, point clouds, as well as mesh data or entire 3D scenes can also be imported to the search framework. And what the framework then does is first extract metadata that are obvious in the file. For example, the file name, which names are in the file name, or which namings are in the 3D scene, maybe EXIF data of JPEGs and so on. This will all be included in a JSON file representing the material, the asset in the database. And on top of that, deep learning methods were trained to detect more information in the images. Currently it's based on images, so if you have a 3D scene, it will be rendered, and then an image recognition algorithm will be applied to those rendered images, and then you get some sort of scene understanding that is provided in the search engine. What I will show you now is a small demo of the search framework. As I said, it's a minimal prototype which shows the search of smart assets. So, for example, it's now here searching for the keyword Jeep. Can you read that actually? Yeah. And so the first step is just grabbing the name Jeep from the names of, for example, material files or the naming of the 3D file, and it will be found, obviously. But we can also go beyond that. For example, if we are searching for, let's say, barrel, and the keyword is now only present in one of those images, in this one here. And actually the other barrel was found because it's looking similar to the barrel that is actually having the name barrel in its description. So that's a similarity search directly integrated into the framework. Let's actually move on. There's some more results. For example, with the keyword mushroom, it might get a little difficult. You will get textures for a mushroom, you will get a mushroom 3D asset, but you will also get a tree which is actually looking quite like a mushroom. So it's not yet at all perfect, but I think you get the idea behind it. Now there's also a so-called cross-modality search, which we can see if we are searching, for example, for tent. You can see there is the texture of a tent, there's the actual FBX file of a tent, but there's also a video which actually includes a tent, provided by the search. And we can actually now also click on the video file here, which will execute another search, similarity search. So in this example, the top 20 similar assets were other videos of the same scene that are found directly through the search framework without any folder or naming evaluation. And what can also be done is, if there, for example, is this Jeep in the scene, it will not only provide all videos that are actually showing that Jeep, but also the 3D model that was used in the video, only based on the search that is executed through the video file. So this is the current state of the search engine, and this will be extended massively, and there will also be added transformations to the assets that are found but that's going to happen in the rest of the source project. Next, I would like to talk about light fields. So maybe some of you have already attended the FMX talk about light fields from us, and I will give some other or new insights into this topic again. So the research within source about light fields tries to tackle the challenges and advantages of light fields in film productions. So with light fields, in general, you want to get more data on set. So what you do is you will use a special camera rig, which consists of multiple individual cameras that are recording the same scene at the same time with a synchronized shutter. And you will get a lot more information from that. I will go into detail about the technical stuff in a bit. But what you can do with that technology is actually to refocus the material in post-production. You can do shallow depths of field in post-production. You can also use tilt shift perspective changes. You can try to use super resolution approaches to improve the resolution of the original footage. You can do 3D reconstruction out of the camera data. And in a way, chroma keying might get easier as well, because you can actually get depth information from that shot material. And much more. So for us, this is how our light field stuff looks like. It's a very flexible setup, not yet really handheld. So what we have here is the actual aluminium rig, which houses the cameras, which can be rearranged in any way you can imagine. So you can adjust the space of the cameras and so on, also the shape. So these are now 8x8 cameras, but you could also have maybe 20 by 2 or whatever you can imagine. And in the middle, you can see that actually each camera is connected to a single computer, which is housed in those boxes in the middle here. So these computers will basically cache the images that are recorded by the cameras, and there is an external trigger which will shutter the cameras all at the same time. And when the images are stored on the small computers in those boxes, you can record maybe 10 to 15 minutes, and then you need to offload it to a storage server, which is then again running in the background. So it's quite a massive setup for a camera. And so what's light field about, or what's actually a light field camera? As you can see here, all the cameras are placed in with parallel optical axis. They will all look into the same direction and shoot the same scene. They will have a massive overlap of images, so even the camera that is most outside will still capture some parts of the center camera. And that's actually the interesting parts. You not only capture the color of a scene, but also the angle from which that color was approaching the camera. So basically what you can do is you can have that camera and then get new perspectives. Since you know where that light actually came from. And for our array, we had a baseline of around 10 centimeters, and this made up for a baseline of around a meter, and the full coverage of the center cameras was also still available in the edge cameras, What I will show you now is a small video of our first proper light field shoot that was taking place in the Saarland University. What I missed is actually, so if you want to capture like 2 minutes of material, you will need 1 terabyte of data. or you will get 1 terabytes of data. So we needed quite some storage capacity for that shoot that you will see in a second. So here's the video. Actually, there should be audio. Okay. So we were at the Saarland
Today
Studios.
we're here in Studio 1 of the Saarländische Rundfunk with participation of several project partners of the European Union-funded project Source Smart Asset Reuse for Creative Environment. And we have the opportunity to make some shootings with the camera rig that's been used in the project and that you see in the background.
So yeah, here you can see the rig, and we were actually capturing a cello player in front of a green screen. And she was captured multiple times, so she was actually, we were recording 4 voices of her playing. And these 4 voices will then be recombined in post-production.
Okay, danke nochmal.
So yeah, we had different distances to the cello player, and we tried out many possibilities how to capture that. We also had a test shoot in advance.
Dann gibt ihr 5.
And yeah, so this was the shoot in Saarland, and what I will show you now is the preliminary or the final result of our work here. And what you can see in the video now is that we were animating the depth of field and the focus in post-production. We were starting with a very, very shallow depth of field, and starting with sharpness only on the bow, which you will see in a second. And then there will be a tilt shift effect, which will also include the face of the cellist. So now the sharpness area was shifted to the bow and the face, and now it's extended towards the other players in the background as well, all based on the captured material. But for this video, actually, we were using more or less standard tools that are used for stereo pipelines. We were using Nuke, for example, to calculate depth maps, and also to calculate the shallow or the blurring, basically. So it's not really using everything that can be done with light fields yet, because we are still in the field where we need to develop algorithms and get together a pipeline. So I will go on with a small outlook of what can be achieved with light fields probably in the future of the source project. Currently, the Trinity College Dublin is looking indirectly calculating the blurring by blending and interpolating the light fields data. So you have 64 camera views, and if you blur them together in a certain way, you will get a shallow depth of field, for example, and but you need to get somehow around the artifacts that you can see here, since you have still quite large gaps between the cameras, and you need to interpolate between them, or you need to find other ways how to prevent those artifacts. But in the end, you can actually achieve physical correct blurring. You can also have, or you can also try to virtually produce lens effects that can normally only be produced by physical cameras, or can actually not even be produced by those lenses. So, for example, an aperture of 0.01, for example, could be achieved with such light field data. In addition to that, we are still looking into how those camera setups that are currently really work intensive can extract more information from what is actually captured. So we are looking into calculating better or optimal depth maps. We are looking into 3D reconstruction and also extracting surface characteristics or material properties of those capturings. We are simulating motion artifacts, and we're also looking into resolution improvements. And in addition, all that light field stuff can actually be displayed on specific light field displays. Basically, that's one step beyond autostereoscopic displays, where you can actually, without any glasses or stuff like that, you can move around a display and view the displayed content from different angles without actually seeing any artifacts or view shifting, basically. That's what we are going to look into in the next 1.5 years. So the next topic I would like to address is character animation, and it's actually the last topic that I'll look into. So we have one partner called Cinema. Maybe some of you know the company. They are really looking or really involved in procedural animation techniques. They also work on retargeting animations to different characters and doing that in real time for games, but also for movies and in VR. So they are quite often seen around in these areas, and along with the Source project, they were working on stylization of animations based on high-level meaningful controls, which you can, for example, see in this video. So they were retargeting an animation to these three characters, and they can adjust the animation for all of those based on quite high-level controls. So you can say, okay, the back should be curved, or the head should be up, the torso down, whatever you want, and will automatically be applied to the rig and the animation itself. And all these adjustments are actually trained with machine learning. Another partner of us is actually working on a browser-based GCC application. They call it Webgl Studio, and in the Source project they extend that to be able to define behavior graphs of characters. So they can have a behavior graph of that character. They can basically node-based define how a character should move. It's all running in a browser, and they are also working on stylization. So they have a little bit different targets. So what they want to do is they want to have crowds that are driven by a common animation, and those individual characters in a crowd would be individualized by stylization of them. And where should that all lead? For us here at Filmakademie, we are looking into bringing character animation to virtual production as well. Maybe most of you know that we have the tablet tools called VPad, which are enabling virtual production usage on a set. So you will have a tablet, currently an iOS iPad, and you can synchronize the real and the virtual world in augmented reality, and you can have set extensions on that tablet. You can see the real world augmented with virtual objects, and within Source we will add character animation to that, but what we want to do is actually leave the actual animation solving to external tools, like the two tools that you have seen before now. And the bone animations that are authored by those or solved by those software components are then streamed back into VPad and displayed there. What this means is that On the iPad app, for example, you can see pathfinding. You can use floor compensation, which is provided by Cinema. You can have attention areas that define where a character should look at, and all that could be combined with high-level animation commands that are authored on VPED. So basically you can tell a character walk from A to B, and the character will do just that, and will also be scene aware in the process of being animated. So that's actually all I wanted to tell you, so I will give the word back to Volker.
Not much to add. There's 2 more slides. So the first slide, or both of them contain information about data sets that you can obtain from our website. The first is the PHS motion library. And PHS, has anybody an idea what PHS means? Except Paolo? It means Paolo Roberto Scantena, and it's a genius motion capture TD student of Filmakademie right here. And he created a comprehensive database of movements that are like biped human movements, mocap data movement, but in different flavors, in different physical states, in different emotional states, and partners started using that to train their systems. You can get it from that URL down here. And the other one is elements that we shot with a fire dancer, and also some smoke elements in our studio. That was before the shoot that Jonas was introducing, and that's the pure data from the camera. So be prepared for a big download if you want that. So that's the end of our presentation. Again, this is sources at midterm now, and I think there's a lot of things that will come up in the next month, the next year. If you're interested, we have a creative user group. That's the source official website. Join the creative user group to get updates. And I just wanted to mention that if any of you working in Stuttgart or Baden-Württemberg companies find that kind of projects interesting, then talk to your soups. Tell them that that seems to be an interesting opportunity to engage in research with academia. An EU project might be a bit too ambitious for the beginning, but there are other ways of trying to find funding to do collaborative research between academic institutions like ourselves, Filmakademie or HDM, and the industry part in that project is really important, because that's one of it's the way to make sure that you work towards something that can be used in a practical environment. So, with that, I would like to thank for your attention.
Well, ladies and gentlemen, there's still room for questions and ideas to the source project. If you have any, feel free.
So what's kind of the final output of the project? So I think the Foundry is mainly interested maybe in putting that stuff into a commercial product, and you're aiming for open source maybe. So we
cannot speak for Foundry.
Okay.
All I can say is that the Flix team is heavily involved in that project, and there will be demonstrators around that technology. I can say something else from the point of view that I understood in those projects from industry partners. It's not necessarily sometimes to have a polished product or a fully functional tool that works in their pipeline, but to get an understanding of the complexity and the topics, and to meet people that can help them with those kind of things from academia. So that again, we can speak for the big industry partners in that project, but it's a mixture of where does the future go, and how do we position ourselves in this. And again, building those consortiums is a tricky part. You're asked at a very early point to contribute upfront to a proposal which usually has about 150 pages. and it takes really time to do that. So you're putting a lot of effort into trying to get the project, which has a success rate of 3 to 4%. So it's those projects are very ambitious. So, but there's other ways,
There's a lot of topics feeding into it. So
yes, of course.
3 years time. But a question to the light field rig. There are many attempts in the last years building these rigs and building the technology to handle this data. Can you give some specs to that rig? Is it special in some sense?
Yes, it actually is special in a sense that I actually didn't mention in the presentation. So the University of Saarland, who were building that rig, actually called that 5D light field. So what they actually want to do is to explore what can be achieved by not shuttering the cameras all at the same time, but maybe interlacing them or exposing them at different exposures. That's all achievable since it's so disconnected from each other. So each camera is connected to an individual computer, and thereby they can really drive any camera individually as they wish. And so that's the speciality about that light field rig.
And the project as a whole, it's mainly focused on the technical side, isn't it? Or is there actually part also investigating the artistic use of that? I mean, you are.
That's part of our. That's part of our task. So we for the unfolding production. Of course, Saarbrücken provided the rig and technology, and they talked to Saarländischer Rundfunk to get access to the studios. But we worked with a DOP that works at Filmakademie, Matthias Bollinger, to come up with a script, that would make use of the light field, depth of field control.
With all the restrictions of this awkwardness of the setup. And,
so our role is of course within Source is to a certain degree technology development for VPET, but also to take the prototypes and the early demonstrators and put them into a creative environment and see what we can make use of, what we can achieve as a creative tool.
And there's also work by a partner on user interfaces to actually author, for example, that depth of field in light field footage. So how can you actually interact with that material to produce such effects, and how can you define from where to where something should be sharp and stuff like that. So there is quite some work in that area.
Interesting. Any other questions? If not, there's plenty of time later on, I think. Had a beer with Jan also. And before we conclude our session, as a tradition, I would like to ask you if you have any idea, anything to speak to us, any ideas to present, any problems you may have for us as an open stage. We would like to give you the opportunity to have a speech at a talk or something.
We're also thinking about streaming the Tech Talks, not live into the web, but there is an Black Forest Games in Offenburg who would, as I understand, has a big interest to being connected to that group, and I'm sure they would contribute with talks more from the game development area. But I mean,
it's a good point. If you have any topics you would like to hear of, please feel free to send us some notes and ideas what you would like to see at Tech Talks. And Volker and I and Film Commission CRS are glad to see you next time in October.
Yes.
At the 7th Tech Talk. And today it's my pleasure to thank you very much for the presentations. Thank you very much for the kind and nice audience we have today. And I have seen what's already set up for us to drink and eat. Thank you very much for everything you prepared for us. And a big thank you.
Did it.